Hello beautiful people, it's Miss Beeching here. In this video I'm going to explain what linear equations are and how to write two-step linear equations from a situation. So these are a bit trickier than the equations from 4.4 or 4.5. Now this is the first time we've talked about linear equations kind of directly. So what are they? They're just an equation that goes up or down by the same amount every time. So if you go up one step in a matchstick pattern, for example, then it would go up by the same number of sticks each time. Say each step of the pattern goes up by 3 sticks or 5 sticks. They're the most simple type of equation because they go up and down by the same amount every time. And they're called linear equations because they make a straight line when you graph them. So there's other types of equations that go up by a changing amount each time or go down by a changing amount each time. So the basic format of a linear equation would be something like this. This one's just an example. You could have other numbers. Let's say an equation like this, you've got two kind of main components that you need to know to write it. First part is this part here. And this part says that the pattern goes down by 3 each time because it's negative 3 times x. And because this says how much it goes up or down by each time, we call this part of the equation the rate of change. And that's one key piece of information. Always got to know the rate of change to write an equation. And the other key part of the equation is this part here. So this part says that we start the pattern on 5 when x is 0. So because this is where it starts on, we call this the starting or the 0th value because it's where x equals 0. So we're going to do a few examples today where we find the rate of change and the starting or 0th value and use those two pieces of information to write the equation. So if you've got these two, you can write a linear equation. So let's actually practice that with a worded problem. And I'm going to put the little steps that we need to follow up on the screen as well for you to use. Okay, so we've got our steps here. And we're going to try and follow these. You don't have to use these steps, but a lot of people find them helpful as we go on. And this example here is our first example we're going to try. We're going to do 2 of them. This one's probably the trickier one of the 2. So let's actually read the information. Mr. Mole left his burrow that lies below the ground, that's important, and started digging his way deeper into the ground. So I'm actually going to start drawing my key information so that I don't miss anything. So let's draw a cute little Mr. Mole in his burrow. And I have a terrible burrow, and here's Mr. Mole with some cute little terrible legs. He's gorgeous, and anyone who says otherwise is wrong. He's beautiful. Okay, so here's Mr. Mole. We know that he's already partly underground, and we know that he's digging deeper. And it says descending at a rate of 1.8 meters per minute. So we know that he's going down at 1.8 meters per minute. That's important. After 5 minutes, he was at 13.5 meters below the ground. So we know that after he digs for 5 minutes, so we're going to say this is the 5-minute mark, he is at a depth of 13.5 meters. Cool. So we've identified the key information in the problem. Okay. Now, what do we know? We know all the stuff that I've drawn. What do we still need to work out? Well, we still need to know what depth he started at. We don't know this, right? And we don't really know how far he traveled either, but we're gonna have a look at that in a second. And I'm gonna try not to erase everything I've just drawn. It's gonna have green on it. That's fine. Okay, so our next step is to define our 2 main variables. So what are the 2 things that change in this problem? So have a think. What is changing in this problem? Well, we know that the amount of time he spends digging is something that changes. So I'm going to define that as a variable. So I'm going to say t is the time spent digging. And have a think, what does the time spent digging actually affect? Oh, well, it affects how deep he gets. So let's define that as well. And I'm going to say d equals Mr. Mole's depth in meters. And see how I've put my units on each of my variables. Really important. Okay, cool. So we've defined our variables. Now we need to do the really important step. We need to work out the rate of change and the zeroth or starting value. Now, conveniently in this problem, the rate of change is already given to us because we know that he's digging downwards at 1.8 meters per minute. So I'm going to say rate of change, and I'm kind of jumping around the page here, so you'll have to forgive me for that. So his rate of change is 1.8 meters per minute. Now the starting value we don't know yet because that would be Mr. Mole's initial depth, how deep he started before he started digging, because he was in his burrow underground already. So we need to work that out. And often I find a table of values is really helpful to do this. So let's draw one up. I'm going to pause to draw that and come back. Okay, so I've set myself up a little table of values here where I've got the depth of Mr. Mole up the top and the time he spent digging down the bottom. And importantly, I've included 0 in this table so I can work out the starting value, because what I'm aiming for is to find his depth when the time was 0, because that's when he started digging. So let's actually fill in the information that we already know. We know that at the 5-minute mark, he's at 13.5 meters. And we also know that he's digging downwards at 1.8 meters per minute. So we can work backwards from that piece of information to help fill in the rest of the table. So if he's digging at 1.8 meters per minute, we take away 1.8 to get to each of these previous steps. And you could do one step at a time, subtracting 1.8 each time if you want to. I'm going to take a shortcut here because I know that to get to 0, I need to subtract 1, 2, 3, 4, 5 lots of 1.8. So I'm just going to work out 5 times 1.8 and then take that away from our 13.5 meters. Cool, so we get 9. So we know that he dug 9 meters in 5 minutes. So that means that his depth here is going to be 4.5 meters. So we worked backwards to find our starting value. So now we know our starting value is 4.5 meters. So we've got our 2 main pieces of information. We're ready to write our equation. So let's do that. And I'm actually going to rub out this part just so you guys can see it a little better. But you guys know what the variables are already. So in this situation, we are saying, okay, well, the depth that he dug at equals something times time plus his initial depth. So we know he started at 4.5 meters, and we know that he's digging 1.8 meters each minute. And so that gives us our equation. Woohoo! Hooray! Winning! Wonderful! Now, when you're writing an equation, you should substitute into it to check your answer. In the interest of not making this video too long, I'm not going to do that here, but you can check the notes in the gather section to see how I've done that. But you just pick a value for t and check that it gets the right answer. But we're going to move on to our second example. Alright, so we've got our second example up here. And we're going to follow a similar process to write an equation for this one. So it says Siraj took a slice of pizza from the freezer and put it in the oven. The pizza was heated at a constant rate. The relationship between the pizza's temperature in degrees Celsius and the time since Siraj started heating it in minutes is given by the table below. So we've been given a table, but you might notice that some of the numbers in the gaps are actually missing. So we're going to need to fill those gaps in a little bit. And it says write an equation that describes this situation. So let's try and write that. Identify the key information. Well, it's kind of given to us in the table, but we know that the pizza heats up at a constant rate. And we also have that table. I'm not going to write the full table out again, but you can read it. So that's our key information. Cool. Let's move on to defining our variables. So this is a little bit easier to define the variables in this problem because it's kind of already given to us in the table, which is nice. So that makes it pretty easy. We know that our variables are the time that it takes for it to heat up and the temperature. So let's give them letters. Remember that you can give them whatever letters you like. I'm going to say that lowercase t is the time in the oven in minutes. And the capital T is the temperature of the pizza in degrees Celsius. So we've defined our variables. Woohoo! Now we're ready to find the rate of change and the starting value. And this one's tricky because we haven't been given either of those two things. So we're going to have to work both of them out ourselves. And we're going to do that by looking at this table of values. Okay, so I've drawn up a table of values just like we did in the previous problem, but I've got the gaps that are missing here. So we know from the table 3 of the values for the temperature of the pizza. And so let's put them in. And we can use these to work out the rate of change. Because we know that between 7 and 13, there were 6 minutes. And we know that between those two times, if we subtract 47.5 from 92.5, we know that that went up by 45 degrees. So that means in 6 minutes, we gained 45 degrees Celsius. So that means in 1 minute, we can just divide by 6 to work out that we gain 7.5 degrees. Right? And now that we know that we gain 7.5 degrees each minute, we've got our rate of change. So let's write that. So we know our rate of change is 7.5 degrees per minute. And now we need to find our starting value. So I don't actually need to fill out any of this part of the table. I could if I wanted to, but really all I care about is finding this zeroth value. So I'm actually going to work backwards from 2.5 and go back by 7.5 degrees. And that means that the starting temperature of the pizza was -5, which makes sense because that's about how cold a freezer is. So our starting value is -5 degrees. Now we can write our equation. So let's clear some space and do that. Cool. So we've got our variables, so we know that the temperature of the pizza equals something times the time, and then plus our starting value. Now we could write this as plus -5, but that's a bit gross looking. So I'm just going to write it as take away 5. But it means the same thing as plus -5. And then the coefficient of t, lowercase t, is going to be our rate of change. So that's the 7.5. And that's our equation. Again, you can substitute into it to check, but this video is already very long, so I'm going to stop there. Thanks. Bye.